Yeah, for each one of these questions, so for this one, I want you to evaluate this, write the answer in fraction form. For number 6, for each one of these, tell whether the number is rational or irrational. Okay, you do not have to explain your answers, just put R for rational or I for irrational. Okay, so just have that little self-check. I'll show you the answers in a minute. Okay, so here's your answer for the first question here. In fraction form, the fourth root of 81 is 3, because 81 is 3 times 3 times 3 times 3. And 625, the fourth root of 625 is 5, because it's 5 times itself 4 times. So 3/5 is your answer there. For number 6, these are the answers here. A is rational, -2, because it can be written as a fraction, ratio of integers. 17 is rational. Root 16 is rational because it's a perfect square, so it simplifies to 4, and that decimal terminates. So just because you see a root sign doesn't mean it's irrational. If it simplifies to a decimal or a number that terminates, then it's rational. 32 is irrational. If you check on your calculator, the square root of 32 looks like this, square root of 32. That decimal neither repeats nor terminates. If your calculator screen fills up with decimals and none of those blocks of numbers repeat, then you can safely say it's irrational. And 32 is not a perfect square. So this decimal is rational because it terminates. It ends after the 6. There's no more decimals. So rational. This is rational because this 3 is a repeating part of the decimal. So if any part of it repeats forever and ever, it's rational. And 0 is rational because it can be written as a ratio of integers. Good? Any questions about that? Okay, 2 more. Here they are. Oh, there they are on another page. Okay, cube root of 81. Irrational. Because 81 is not a perfect cube. Okay? That would be 3 to the 4. So it would be the fourth root would be okay, but not cubed. And then pi is irrational because in decimal form it neither repeats nor terminates. Pi famously is, one of the irrational numbers that people have searched to try and find as many of those decimal places as possible. It's a very important constant in math. Okay, good. Now we got that. Any other questions? All right, let's do a couple more. So write each radical in simplest form. So simplest form is going to be in mixed radical form if possible. So see if you remember how to do that. All right, so when you're changing a radical to simplest form, what you want to do is you want to explore this number, factor it, so that you have a perfect square factor. And to get to the right answer right away, you want the largest perfect square factor. So for 150, the largest perfect square factor is 25. So 150 can be written as root 25 times root 6. Root 25 is simplified to 5. So 5 root 6. Okay, the next one here, 135. Okay, a largest perfect cube as the factor that you can find would be 27. So therefore this reduces to 3, and that cannot be reduced anymore. There's your final answer. Okay, so fourth root 1, this one's maybe a bit tricky, but you want to find a perfect fourth, a number that can be multiplied by another number 4 times as a factor, right? And so 81 is a factor of 162, so this looks like your reduced form there. Any questions on that one? Are you able to do that? Okay, if you're able to do that, that's good. Okay, for the next set of questions here, these are mixed radicals. Write them as entire radicals. See if you remember how to do that. Okay, so as you check these numbers here, again, if you have a square root, okay, if you have a square root, then this number can get into the square root club by becoming squared. Right? So 6 squared here, it can go underneath. And you have 36 times 5. Okay? Same thing. Now I'll show you the actual answer key here that I have, because it shows some more steps and just a little bit different way too, so it gives you a little extra reasoning there. But again, the 3 becomes square root of 9. right? And you multiply those through. So those are your answers there. Okay, how many of you got all four of those correct? All four of those correct? Okay. All right, good. How are you guys feeling about the upcoming test? Out of 5. 5 is I'm going to ace it. 0 is, I could get a -% if possible. Where are you at? Show me how many fingers. 5, super confident. 4, pretty confident. 3, so-so. 2, not really. 1, I'm pretty bad at this. Where are you? Okay, I'm just looking around here. Okay. Okay, good. I'm seeing lots of 4s. That's good. Okay, lots of 4s is good. It's a good average. Okay, so the last question on your little prep quiz here is number 27. It's a word problem. Now, the nice thing is they give you the equation. They make it pretty simple, but let me read through it. It says, when musicians play together, they usually tune their instruments so that the note A above middle C has a frequency of 440 hertz, called the concert pitch. A formula for calculating the frequency F, hertz, of a note N, semitones above the concert pitch is. Now, all of that stuff is just a little background to the whole situation. You don't have to understand what a semitone is or what a hertz is. You don't have to. They give you the formula right here. This is what you want to focus on. Middle C is 9 semitones below the concert pitch. What's the frequency of middle C? So F is the frequency. And what was N again? Semitones above the concert pitch. Oh, so what do we do if middle C is 9 semitones below? What do you think we should do? I'm going to give you a chance to do this question, come up with the answer, and I'll give you the answer in a few minutes. Okay? All right, so here's the solution to number 27. If N is semitones above concert pitch, and you're given that C is 9 semitones below that, it might be a good thing to try to substitute N equals -9 into the formula. So, of course, you can use your calculator here, and whichever calculator you're using, just make sure that you know how to do this on your calculator. Very important. Okay? So, use your brackets and everything. This -9 only goes to this one. Do not do the multiplication first. You have to do this exponent first. So, even to make sure of that here, let's see, on my calculator I have to do this, but you just figure out what you have to do. I have to say 12th root of 2 to the power of -9. I'll do that one first. And then that's this part, and then times 440. I think that's the way I have to do it on my calculator. Okay? So get this one, 261.625. So that seems to make sense. Rounded to the nearest hertz. There it says in the question, see? Nearest hertz. So 261.6 would be 262. All right? Okay. How many of you got this answer correct before I showed you the... Okay? All right. You guys are in good shape.